Find two positive numbers whose sum is 196 and the sum of whose squares is a minimum. So we're looking for two positive numbers, and let's call them x and y. There are two quantities involved. There's the sum of the two numbers, and there's the sum of the squares of the two numbers. I'm going to call that Q. We want to minimize the sum of the squares given that the sum is equal to 196. So I'm going to substitute 196 for the sum. And then I'm going to solve for y so that I've written the second number in terms of the first. It is 196 minus the first. Now if I take that value of y, I can substitute it into the second equation. And see that what I'm getting is a quadratic function, q of x, in terms of x, the first of the two numbers. A quadratic function has the shape of a parabola, so we will go ahead and try to find the vertex of the parabola. So let's expand the right-hand side by squaring the binomial. I've worked this out on the calculator, and it's 38,416. That's the square of 196 minus twice the product of 196 and x. That's 392 x plus x squared. Combining our x squareds, that gives us 2x squared minus 392x plus 38,416. Now, you may recall that for ax squared plus bx plus c, that function, the vertex will have first coordinate equal to the opposite of b over 2a. So in this case, the opposite of b is going to be positive 392 divided by 4. 4 goes into 39 9 times, remainder 3, 4 goes into 32, 8. So the first coordinate of the vertex is 98. And that is going to be the x coordinate that gives us the minimum value for the sum of the squares. And we're actually not asked what that minimum value is. Certainly we could compute it. That minimum value would be Q of 98. And I'll let you compute that. But what we have determined is that the x coordinate of the vertex, the value that minimizes the sum of the squares, is x equals 98. So if x equals 98, we go back to the equation y equals 196 minus x. 196 minus 98 gives us also 98 for y. So the two numbers that minimize the sum of the squares are each 98. Notice they do add up to be 196. The minimum value of the sum of the squares would be 98 squared plus 98 squared, and that's 19,208. And that's the same value that you would get if you substituted 98 into q of x. But our answer, the two numbers are x equals 98 and y equals 98. There is a second way that you could have gotten the x that created the minimum, and that is you could have completed the square of q of x, and you would have gotten the coordinates of the vertex to be 98, 19,208. Again, you want the x value because that represents the first number in the pair that minimizes the sum of the squares.